Today we are working with 4 techniques for solving quadratic equations. The first technique we will discuss is the graphing method. Remember, the shape of a quadratic function is a parabola or U-shape. The real solutions to a quadratic function are called the zeros of the function. Graphically, these are the x-intercepts. To solve a problem graphically, simply get one side of the equation equal to 0, enter it into the y equals on your calculator, graph it, and then find the zeros of the function. You can get close with the trace function, but you will get a more accurate solution using the calculate zero function. It's found on second and trace. Here is an example. We have the problem z squared minus 2z minus 24 equals 0. I can see the graph on here, and it looks like it crosses at -4 and +6. Let's check this out with our calculator. First, I'm going to enter y equals x squared minus 2x minus 24. I'm going to graph it. It looks like it crosses at -4 and +6, but to be absolutely sure, I'm going to go to second, trace, and notice that choice 2 is the 0, so I'm going to push 2. Now, to find the 0, I have to tell it 2 numbers that it's between, and I can only check for one at a time. When I'm looking for this one on the left, it looks like it's at -4, so I would say that is between -5 on the left and -3 on the right. So I simply type in -5 and enter when it asks me for the left boundary. When it asks me for the right boundary, I type in -3 and enter. When it asks for a guess, I could guess -4 and see if it works, or if I'm really lazy like I am, I can just press enter and the calculator will actually calculate it for me, and the 0 was at -4. Now, I would check the other side. I would actually have to repeat the entire process. So second, trace, choice 2 for 0. This time I'm looking at the one that I think is at 6, so that's between 5 and 7. So for left bound, I type 5 and enter. For right bound, I type 7 and enter. And if you look above it, you can actually see on your calculator there are 2 little arrows up here that are pointing at the region that your calculator is going to look at for the solution. I would then press enter, and it does tell me that I do have a 0 at 6 and 0. The second technique is to solve the problem by factoring. So that means we actually need to be able to factor the equation z squared minus 2z minus 24. If you have forgotten your factoring techniques, you can always refer to the podcast or video on factoring. Here we go. First, one side must equal 0. Now I need to factor this. This is an easy factoring problem. I know that to get the first term of z squared, I need a z in the front of each of my 2 binomials. Then I know that I'm looking for 2 numbers that when I multiply them give me -24, and when I add them give me -2. Those 2 numbers happen to be -6 and +4. So now my problem is z minus 6 times the quantity of z plus 4 equals 0. I apply the zero product property by setting each factor equal to 0. Z minus 6 equals 0 gives me a solution of z equals 6. Z plus 4 equals 0 gives me a solution of z equals -4. This is the factoring technique. Easy in this circumstance because there's no lead coefficient. Sometimes they get to be a little bit trickier. The third technique is the trickiest technique. It's called completing the square, and it allows you to use the square root property to solve it. It will work for any quadratic equation, but it is best not to use it if the lead coefficient is not 1. On our example, since it is 1z squared, this is a good time to use it. The first thing we want to do is we want to move the constant term to the other side of the equation. This is the only technique where we do that. So the first thing I'll do is make that z squared minus 2z equals 24. Notice that I left a blank in the middle. And the reason I left a blank space is because on this left side, I'm going to turn this into a perfect square binomial by adding something to it. So I need to figure out what that is, and then I need to add it to both sides. So the technique to do that, first I am going to go ahead and set up my binomial. I know it's going to be something squared equals a constant on the other side. I know that the variable had to be z. Now, to determine whether the sign in here is a plus or a minus, I'm actually going to go back up and look at the sign of the linear term. And the sign of the linear term was a minus there. It was minus 2z. So I'm going to use a minus in this position. Now, to figure out what I'm going to add to both sides, the first thing I'm going to do is I'm going to take that linear term, which was negative 2. I'm going to take half of it. And half of negative 2 is negative 1. I know for this to be a perfect square trinomial, my last term has to be half of the middle term squared. So I'm going to square that, and negative 1 squared is a positive 1. Since I'm adding 1 on the left in order to keep my equation balanced, I also have to add 1 on the right. So my problem is actually z minus 1 squared equals, and on the right side, 24 and 1 is 25. At this point, I can apply the square root property, taking the square root of both sides. The square root of z minus 1 squared is actually the absolute value of z minus 1 by definition, but we accommodate for that by making sure that when we take the square root of the other side, we get plus or minus. That accommodates the fact that we don't know if what was inside the square root, what was squared, was actually a positive number to get 25 or a negative number to get 25. Now the square root of 25 is 5. I actually have two equations here. One is z minus 1 equals 5. The other is z minus 1 equals negative 5. Solving both of these equations, I get z equals 6 or z equals negative 4. Again, exactly the same two answers that I got with the first two methods. The fourth technique we'll be using is called the quadratic formula, and it is actually derived from completing the square. This is probably one of the easiest ones to use. Some of you know a version of it to Pop Goes the Weasel to memorize it. Some of you know another version of it to have memorized it. I will play a tape for you in class. You can pick which one you like. It is actually x equals the quantity of negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, this has a couple of parts to it. One part is negative b over 2a. The negative b over 2a part of it, you may remember as how you find the vertex, the x value of the vertex in a quadratic equation. Then there's a plus or minus, and then the other part of it is the square root of b squared minus 4ac all over 2a. Now, the b squared minus 4ac part has a name. It's called the discriminant. Notice the discriminant is not the square root, it's just the radicand, or the number inside the square root. And we can use that to actually determine the nature of the roots, or zeros, and the number of the roots in the problem. If it's a positive number, when you take a square root of a positive number, you get two values. You get a plus or a minus. If it's 0, the square root of 0 is 0. So when you add it or subtract it, you still only have one answer. And if it's negative, the result will be two imaginary roots. Now let's take the same problem and solve it using the quadratic formula. First off, the original problem was z squared minus 2z minus 24 equals 0. Again, the only time you want the other side to be a number other than 0 is if you are completing the square. For this problem, a is 1 because the coefficient of z squared is 1, b is negative 2, and c is negative 24. Now, you can go ahead and substitute directly into the quadratic formula, or you can make your life a little bit easier and find the discriminant first. So let's find the discriminant. Remember, the discriminant is b squared minus 4ac. So in this problem, I'm going to have negative 2 squared minus 4 times 1 times negative 24. Now, remember, when you're squaring a negative on your calculator, you absolutely positively need to put it in parentheses, or remember on your own that when you square a negative, you're multiplying two negatives, so your answer is positive. So that's 4. In the remainder of my problem, I have two negatives multiplied together, so that's going to be a positive, and 4 times 1 times 24 is 96. That means my discriminant is 100. Now, it's positive. What this is telling me to start with is I'm going to have two real roots. I can actually tell a little bit more about it. Not only are they real, they're also going to be rational. And the reason they're going to be rational is because the square root of 100 is 10. It's not anything that's ugly. It's not one of those ugly decimals floating around. Now I'm going to go ahead and substitute this into my quadratic formula. So it's going to be negative b, which was negative 2, plus or minus the square root of 100. I already figured out that b squared minus 4ac was 100, all over 2 times a, which was 1. A common mistake is to forget the 2 times 1. Be careful with that. Now, two negatives make the first value be positive 2, plus or minus the square root of 100 is 10, all over 2 times 1, which is 2. This means I actually have two problems, 2 plus 10 over 2 and 2 minus 10 over 2. When I do 2 plus 10 over 2, that's 12 over 2, which is 6. When I do 2 minus 10 over 2, that's negative 8 over 2, which is negative 4. This concludes our lesson on solving quadratic equations.